All right, today is the absolute value equations. So a couple days ago we did absolute value functions, and those were equations where there were two variables, and so if you give me an x, I can give you a y. And if you give me a different x, I can give you a different y. So on these, it was like y equals x. So there's multiple right answers to this equation. You can graph it. The problems we're doing today, there's only one variable. So, like example, the absolute value of 3x plus 4 equals 5. There's no y, which means there's only one answer. Well, in this case, there's going to be two answers most of the time. But there's a locked-in answer. It's not a graph. Okay, or not a graph on a Cartesian plane. So to start out with here, absolute value means distance from 0. And a distance can never be negative. So a distance can never be negative. And so when I do these, I need to get, when I get an absolute value, the absolute value has to equal a positive value or a 0. If it doesn't, you can say no solution. So we're going to look out for those too at some point. However, when a variable is within an absolute value, typically there's two solutions. Now, why is that? Well, if I told you that the absolute value of a number equals 5, that means the number itself is 5 units away from 0. That could be 5 to the right, it could be 5 to the left. So x is either 5 or it's negative 5. So when you get it down to the absolute value by itself like this, you're going to set that equal to the positive value, and you're going to set that equal to the negative value. So it's either, this is saying 5 to the right or 5 to the left. Okay? Kind of a simple idea when it's just x by itself, the number. So if I set the absolute value of some number is 13, well, that means x is either 13 to the right, which is 13, or 13 to the left, which is negative 13. And then just to kind of keep things, if I said the absolute value of some number equals negative 3, well, I can't go negative 3 units in any direction. So right there, this one's no solution. So anytime you get it down to the absolute value of something is negative, it's not true. It can't happen. So there's no solution. So we almost kind of like those better. Those are quick and easy. You're done. So no solution. Now, I can do that with numbers, but also I can do it with expressions. So that expression, now if I have an expression has an absolute value, like if I say that 2x minus 1, its absolute value is 5, that means this expression is sitting right here at negative 5, or it's sitting right here at positive 5. So either that expression equals positive 5, or 2x minus 1 equals negative 5. So it breaks down into two separate equations. Then from there, it's solve it. Okay, so I got to solve this guy. So if I add 1 to both sides, I get 2x equals 6. Now over here, if I add 1 to both sides, I get 2x equals negative 4. So you see how we're going to get two different answers. Okay, so as you go here, it's going to be two separate answers. And if I divide both sides by 2, I get x equals 3, and I get x equals negative 4. I'm sorry, negative 2. You do want to double check now, because there are what's called extraneous solutions. Sometimes we get answers that, because we split it up, it might make this equation true, but it doesn't necessarily make that one true. So we want to double check that. Sometimes you do this in your head. So if I plug a 3 in here, I have 2 times 3 minus 1, take the absolute value, see if that equals 5. Okay, so 6 minus 1 does in fact equal 5, so that one works. Now plug in negative 2. So 2 times negative 2 minus 1, take the absolute value, does that equal 5? Well, this would be a negative 4 minus 1. Negative 4 minus 1 is negative 5. The absolute value is 5. So that checks out too. So both of these are solutions. It's x is either 3 or it's negative 5. We plug them in and check them. Okay. So let's go through a few of these here. I'm going to go kind of quick. Pause the video if you need to. Okay. So I've got absolute value by itself. This expression, its absolute value is 9. That means x minus 3 either equals 9 or x minus 3 equals negative 9. Because when I took the absolute value of it, I got positive 9. So it's either 9 to the right or it's 9 to the left. It's either here, 9, or there, over here, positive 9. solve them individually. So plus 3, x equals 12, add 3, x equals negative 6. Again, this one's a fairly simple expression inside, so I can do this pretty quick. 12 minus 3 is 9. The absolute value of 9 is 9. So that works. Negative 6 minus 3 would be negative 9. The absolute value of negative 9 is also 9. So that works. So I got to keep both my solutions on this one. Next one here, I've got this expression. If its absolute value is 5, that means the expression is either 5 to the right or it's 5 to the left. So 3x plus 4 equals 5, or 3x plus 4 equals negative 5. Subtract 4 from both sides. 3x equals 1, or 3x equals negative 9. Now, you can solve this one all the way down that one. This is just how I do it. I do the same steps. So x equals 1/3, or x equals negative 3. Now let's check them. So if I plug the 1/3 in here, 3 times 1/3 is 1, 1 plus 4 is 5. The absolute value of 5 is 5. Plug a negative 3 in here. Negative 3 times 3 is negative 9. Negative 9 plus 4 is negative 5. The absolute value of negative 5 is 5. So those both work. Okay? You get something like this, where there's a 2 out front, so 2 times the absolute value. Well, I need to divide by 2 before I do this trick. Okay, I need the absolute value to be by itself in order to say this distance from 0 is correct. So this one, this says twice the distance from 0 is 14. Well, I want to know what's the distance from 0. So I want to divide both sides by 2 first. I got the absolute value of 3x minus 2 equals 7. And now I got, split those up, 3x minus 2 equals 7, or 3x minus 2 equals negative 7. Okay, speeding the process up here for the sake of time. I get, on this one, I'd get 3, and on this one, I would get negative 5/3. And they do both work. Okay, so again, if I plug them back in, they work. Okay, a little bit different of a guy here, number 4. I got the absolute value, instead of equaling a number, it equals another expression. Well, we're going to do the same thing, though. I'm going to set this equal to that positive. I'm going to set it equal to the opposite of that. Because like up here, I set it equal to 9 and negative 9. Well, I'm going to set it equal to this and the opposite of this. So this expression, x minus 1 equals 5x plus 10, or x minus 1 equals the opposite of that. So if you think the opposite of this would be the opposite of 5x plus 10, that'd be negative 5x minus 10. Okay, and now solving these guys, I'm kind of scrunched for room here, but I would, on this one, I would subtract x from both sides. So that brings the x's to the right. I now need to bring the 10 to the left. So I'm going to do it all in one step since I'm running out of space here. So I brought the x's to the right. I'm going to bring the constants to the left. So minus 10, minus 10. So on the left side, I got negative 10. These are gone. This is gone, and I got 4x. That's right, this is minus 11. Negative 1 minus 10 is negative 11. Divide by 4, divide by 4, I got negative 11 fourths. Now when you go plug that back in up here, and plug it in there, I believe this one's positive, this is a negative. When I plug negative 11 fourths in here, I believe I get a negative. Yeah, when I plugged it into the right side, took 5 times negative 11 fourths plus 10, I got negative 3.75. This side can't equal a negative 3.75 because it's the absolute value of something, so it's going to be a positive. So right off the bat, I know this one, I need to throw that one out. That one does not work. Now this one, I'm going to add 5x to both sides. So I brought the x's to the left, that means bring the constants to the right. So here I've got 6x equals negative 9. If I divide by 6, x equals negative 3/2. And when I plug those in up there, I do get the same answer on both sides. So just to save time there, typing your calculator, it does make that balance out. Okay, so now I would say if you have time, I'd stop and do your Math Excel. Numbers 1 through 6. Do numbers 1 through 6. Now that's what those are equations. Okay, so now if we did those, because now this is when I change things up. Instead of being equations, now it's inequalities. So notice I didn't say the absolute value of x equals 5. it's going to be less than or equal, and we also have greater than too. So I lost it somewhere here. I thought I wrote it, but when it says the absolute value of x is greater than or equal to 5, somewhere I lost it along the way here. So that goes here, there. But anyway, so it's going to be a slightly different way of doing it. So if I said, so visually, if we said that the absolute value of a number is less than or equal to 5, that's saying its distance from 0 in either direction is 5 units or less. So it's not that x is here or here, it actually can be anywhere in between. Because it could be 4 units away, it could be 3 units away, it could be 2, it could be 1 to the left, 2 to the left, so on. So it's actually equal in a span. So whenever it says the absolute value is less than something, that means you're between two numbers. You're between the positive and the negative of these two numbers, okay? So it's either it's greater than -5 and it's less than 5. So it meets both requirements, which is what this is saying right here. So x is between -5 and 5 if its distance is less than 5. It can't get further away than 5, so it's actually stuck in between. Whereas if its distance is greater than 5, that means it's at least 5 units away and more. So that means it's going to be going this way or this way. So either x is less than -5 because it's to the left, or equal to -5 because it isn't equal to. But if it's greater than 5 on the other side, that means it's 5 or more. Now you can't put these two together. These can't be put together in one because you can't be less than -5 and greater than -5. But here you could be. You meet both requirements. You can be greater than -5 and less than 5 if you're in between. So you can put it in one statement. Here I have to leave it as two separate statements. Okay? So this is called a compound inequality. If you remember from Algebra 1, you did a compound. It has two inequalities in one. X is greater than -5 and it's less than 5. So it meets both requirements. Okay? So compared to -5, the arrow is open towards x, but compared to +5, the arrow is closed towards x. So it's greater than -5, but it's less than 5. It meets both requirements. So when I do the expressions, same idea. So if I say that x plus 3 has a distance of greater than 9, it's outside that. So think, here's 0. I'm either 9 units this way. Well, it's actually not even equal to, so it's going to be more than 9 units, or it's going to be this direction, or more to the left. So x plus 3 itself, if it's less than left of -9, that means it's less than -9. Or if it's to the right of +9, that means it's greater than. X plus 3 is greater than 9. Okay, so it's going to be outside. So if you need to draw a picture like this every time, whether in your head or actually on the paper, do it. And now solve these individually. So I've got x is less than -12 or x is greater than 6. So if you pick any number less than -12 or greater than 6 and plug it in, it'll make it true. Okay. And on these, there's no extraneous solutions. This is right. You don't have to check it because this is it. Okay, so these are okay. And if I was going to graph that now, because on MathXL it'll say graph it, if x is less than -12, that means -12 here is going to be an open circle going to the left. Any number less than that, well, -13 is less than that, -14 is less than that, and so on. And then any x greater than 6, so over here would be a 6, open circle because it's not equal to, and then going to the right. And that would be my graph. So any number, 7 would make that work. -13 would make that work. 52 would make that work. Or -52 would make that work. So there's lots of answers to this. So when it says the distance is greater than, you're being pushed outside. You have two separate inequalities to solve. This one's going to be the same way. I'll go a little bit faster here. So this, if it's greater than 8 or equal to, that means it's 8 units or more in this direction, and then it's 8 units or more in that direction. So it's being pushed out. So x minus 5, it's less than or equal to -8 because it's to the left, or x minus 5 is greater than or equal to +8. Okay? And then solve those, plus 5, plus 5. plus 5 plus 5. So if I'm going to graph this, here's negative 3, here's positive 13. If x is greater than, it's going to be graphed to the right. If x is less than, it's going to be graphed to the left. If it's less than negative 3. Okay? Now, less than. If a distance is 9 or less than, that means it's between two things. Okay? If here's 0, this expression is either 9 units this way or less, or it's 9 units this way or less. So it's going to be between these two numbers, and that's going to be an equal to somewhere there. So it's kind of stuck between these two numbers. So 4x, whoops, let me write it this way. 4x plus 3 is going to be between negative 9 and 9. So that means it's like this. It's greater than negative 9, but it's less than positive 9. So see how, if I cover this up, that says greater than negative 9. But this way it says less than 9. And here's where you can do kind of three things at once. So like if I subtract 3, I got to subtract 3 from everything. Okay, so when I subtract 3, I got 4x left in the middle. 9 minus 3 is 6. Negative 9 minus 3 is negative 12. I want to get x by itself, so I'm going to divide by 4. So x, now this would be 3 halves, and this would be negative 3. Okay? And one thing you want to look out for, if you do multiply or divide by a negative, you do need to switch your signs. I haven't done that yet. I haven't had to do that at all in any of these yet, so I didn't multiply or divide by a negative to get it to work. It may happen at some point that you have to do that. Okay? And then if I was going to graph this, since x is greater than negative 3 and less than, that means there's endpoints. So here's negative 3, closed circle. Over here, say 3 halves, closed circle, and then everything in between. Okay, so it's kind of a real quick graph of those. Just like the front side, if the absolute value is not by itself, get it by itself. So my first step is I'm going to add 4 to both sides. Okay, now the distance is less than 12. So it's either 12 units or less. So if 12 is over here, it goes up to here or less, or it goes this way to negative 12 or less. So that means you're stuck between two things. Think of like being on a leash. If you're less than 12 units away, that means you got a leash that only lets you go up to 12 units away. But you can go less. I mean, the leash isn't tight then. So that means, so this expression is going to be between two numbers. So 3x is greater than negative 12, but it's less than 12. Now let's divide by 3 to find out what x is. So x, negative 4 to 4. Okay. I'm going a little bit faster here because the video is getting long. I don't want to be too long here, but I'm going to subtract 5 from both sides first. So 3x minus 4. Its distance from 0 is less than or equal to 27. So if it's less than or equal to, that's like it's on a leash. It's going to be between two numbers. It's going to be between, it could be up to 27 units away to the right, or it could be 27 units to the left, which is negative 27. And it can equal those, so closed circle, this way. The expression is between these two numbers. Now I want to find out what just x by itself is. So if the expression is somewhere in between there, that means 3x minus 4 is greater than or equal to negative 27, but at the same time less than or equal to 27. And so add 4, add 4, add 4. So this would be negative 23. This is 3x. And this is 31. Now divide everything by 3. Am I doing this? Yeah. Divide everything by 3. I didn't subtract 5 over here. I thought that felt weird. 27 minus 5 is 22. I'm sorry. I wish I would have caught that sooner. Maybe you were thinking that, like, whoa, what's he doing? Okay, so luckily it didn't change a ton. So negative 22 plus 4 is negative 18. 22 plus 4 is 26. Still not great answers divided by 3, but that's okay. Yeah, I divided by a positive, so no switching the numbers. So negative 6, x, and you just leave that as, well, let's see, that'd be like 8 2/3. Okay, and then graph it on a number line. Number 6, I'm going to have my negative 2 here, so I'm going to divide both sides by negative 2. Now, of course, we're supposed to switch. Since I divided by a negative, I switch it to this. But I got a negative for a distance. nothing can have a distance more than negative 11 because that's not even a thing. So this one is no solution. That one you can't have a solution to it. All right, so now we know this. If you haven't already, go back and do the Math Excel. Do numbers 7 through 10.